Everyone. Congratulations on making it to the last talk in the session, and welcome to a shared vision for the LA River. I'm Mitul Luhar. I'm an engineering faculty member at USC, and this is work done with my colleagues, Alex Robinson, who's a landscape architect, Andreas Kratky, who's a digital media artist, and Gail Lucas, who's a social scientist, on developing a co-design platform for the Los Angeles River and similar climate-stressed infrastructure. So I know many of you won't be familiar with the Los Angeles River. The LA River charts a 51-mile course through the heart of LA, from Canoga Park to Long Beach. It was once a free-flowing river, but it also flooded frequently. And so after a series of devastating floods in the 1930s, the Army Corps decided to come in and make it a concrete-lined flood channel. Flooding still remains a concern, though. So particularly in the soft bottom Glendale Narrows section of the river, which is shown in red in the top left for you guys, where the annual exceedance probability, so think of this as a flooding probability, is over 10%. There's been a lot of interest in revitalizing the LA River so that it doesn't resemble this concrete hellscape that you might have seen in the Terminator movies. And this interest, this interest has really sort of gained steam in the last 10 years or so. And Glendale Narrows is a particularly promising location for this revitalization. The Army Corps has recommended a major restoration plan. Local partners have purchased large parcels for modification and so forth. However, despite these efforts, revitalization plans remain stalled and contentious. Taylor Yard, shown here, is a prime example of this. So Taylor Yard used to be a railway yard and a classification yard in the early part of the 20th century. The city acquired this parcel of land in 2017 with the hopes of turning it into a river park with native wetland regions in time for the Summer Olympics in 2028. Several design proposals have been generated for Taylor Yard, some that include an island, some that include a soft edge, and so forth. But there's little consensus among stakeholders on how to proceed, and very uneven community acceptance on the design proposals. Right, so what we're trying to do here is create a co-design platform that is simultaneously innovative, technically rigorous, and community inclusive. So what we're doing specifically is developing a scaled hydraulic model. This is commonly used by the Army Corps, but we're augmenting it with some augmented reality programming and some really interactive design elements. And this is something that you'll see just in a second. This is housed in a City of LA hydraulics laboratory that's right next to Taylor Yard and the community in question. And you should soon see this scaled model coming into the field of view. So this is an early iteration. This is what it currently looks like. This is a 1/120th scaled physical hydraulic model. This is something that the Army Corps uses regularly, as I mentioned, but we're trying to make it more inclusive. We're trying to make sure that other disciplines can access it and really participate in the design process. So here are a few enhancements that we've made to create this co-design process. We've got an adjustable wall system. We've got a pick-and-place vegetation system that reproduces the hydraulic resistance. And both of these features essentially speak to the design constraints, which are ecosystem restoration and flood control for the most part. Right? And we've got an overhead camera system that can track in real time changes to the model made using a design session. A key component of this model is also the addition of an augmented reality interface. So the purpose of this interface is to be able to integrate multiple data sources, so flood simulations, information from community asset mapping types of efforts, build in multiple layers, show different design proposals. And in addition, we want to let people really interact with this model. So here's an example where people can leave comments, potentially. Here's an example where people can draw on the object, perhaps show where trees should be planted, and so forth. Sorry, a tree will be drawn in just a second, potentially. Is there a tree that will come up? There we go. And so here's an example showing different flood simulation. These are still very preliminary. We're going to integrate high-resolution simulations from the Army Corps. And there's an immersive walkthrough technology feature that we're building in as well. So that's something that will show up now. So you can walk off into the sunset along the Los Angeles River. So this is very much a work in progress. We need to integrate multiple data sources. We need to create educational programming and user testing, so both in the form of focus groups and quantitative testing to see whether this co-design platform is effective is planned for the fall. And I should, at this point, thank the student teams that have been developing all of this, and Graham Nash, who's the lab manager, as well as our project partners, so the City of LA, who are providing the space, the Army Corps, who are helping us build the model, a local community arts organization, Clock Shop, as well as our funding sources. With that, I'm going to stop. This is, as I said, this is very much work in progress. We would welcome feedback on the AR system, on co-design, on public engagement. I know there are experts on all of these, climate resilience, all of these things in the room here. Please come and talk to me. We'd love feedback. We'd love collaboration. Thank you.